This video is covering the lesson Proving Line Parallel. And one of the things that we learned from our last lesson is if we have parallel lines and they're cut by a transversal, there's certain things that we know about all these angles. In this lesson, we're going to actually talk about what, if we know certain things about angles, can we prove the lines are parallel? So first, let's review alternate interior angles. I'm just going to mark all my alternate interior angles. Whoops, that's not alternate interior. Alternate interior, 3 and 6 are alternate interior, and 4 and 5 are alternate interior. So 3 and 6 are congruent, and 4 and 5 are congruent. Alternate exterior, remember those are the ones on the outside and opposite sides. So 2 and 7 are alternate exterior. What are the other alternate exterior angles? In this case, they're 1 and 8. Same side interior angles. Same side interior angles means they're on the same side of the transversal and the inside, so between the parallel lines. So 3 and 5 are same side, and 4 and 6 are same side interior angles. And we know that those equal 180 degrees. They're supplementary. These are congruent, and then finally our corresponding angles we know are also congruent. And in this case, our corresponding angles are going to be 1 and 5 are corresponding angles because they are on the same side of the transversal and the same side of the parallel line, meaning at the top of the parallel line or the bottom. So 1 and 5, 3 and 7 are corresponding, 2 and 6 are corresponding, and 4 and 8 are corresponding. Make sure you understand and know those definitions. So let's take a look at these. If we know that M and N are parallel because we have these little hash marks and P is a transversal, which pairs of angles are congruent? So pause for just a second and mark the ones that you think are congruent. And I'm going to write the reason why. Okay, check your work. You should have marked these three. 1 is corresponding, 6 and 4 are alternate exterior, and 8 and 2 are alternate interior. 3 and 8 are same side, so they are not congruent, they are supplementary, and 4 and 7 are they're exterior angles, they're same side exterior angles, but we don't know about those. So here's another important definition. When we're looking at these things, a converse is a statement formed by switching the hypothesis and conclusion. So basically what we did before, we said if a transversal intersects two parallel lines, then we know corresponding angles are congruent. So now we're saying the opposite. If two lines in a plane are cut by a transversal and then the corresponding angles are congruent, then we can say that the lines are parallel. So we have a condition, a statement, and then switch it to be the converse. So we're going to be proving some converse statements because we've already proven some of these. If there's two parallel lines cut by transversal, we get certain congruency. So we're going to be looking at some converses today. So if we take a look at this, this is the specific one. The first thing, in the first one, we're given parallel lines, and then we prove corresponding angles. So we go from here to this. In the converse, we're given this, and we want to prove that they are parallel. That's another way of thinking about it. So, which diagram represents the hypothesis of the converse of the corresponding angles theorem? So, meaning we want to prove that if corresponding angles are equal, then the lines are parallel. Well, which one of these diagrams show corresponding angles? It's this one right here. Those two are corresponding angles. These two are alternate exterior, and these two are alternate interior. So this represents if we have two congruent angles that are corresponding angles, then, and we're going to try to prove something. All right, let's look at a different type of thing. Here we've got 3 lines now that are cut by transversal, and we want to know which lines, if any, are parallel and why. So a few things that we know. We know they all lie on a plane. They're cut by transversal. We know angle 1 is supplementary to angle 2. So angle 1 plus measure of angle 2 equals 180 degrees. And we know 2 is supplementary to 3. Measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Now there's more than one way to do this, but the way we're going to look at it is based on this information, and particularly this second piece of information, 2 and 3 equal to 180. What do we know about 2 and 3? If we kind of ignore L there for a second, because there's no angles we have associated with angle L. So then we just look at 2 and 3. What do you notice about 2 and 3 in relation to M, N, and the transversal? Well, they're on the same side and interior angles. They're same side and interior angles. And what do we know about same side interior angles? We know same side interior angles are supplementary. So if that's the case, if 2 and 3, then M and N would be parallel because the converse of the same side interior angle theorem, meaning if we had the interior angle theorem says if we have two lines that are parallel, then these two are supplementary. So the converse would say if these two angles, the same side interior angles, are supplementary, then the lines are parallel. So let's walk through this proof. So if we're given angle 1 is congruent to angle 2, and we want to prove P is congruent to Q, or parallel, not congruent. P is parallel to Q. And in this, it kind of gives you several different angles, reasons, statements. So we're just going to try to walk through this. So we're given angle 1 and angle 2. Well, here's our first clue. Angle 3 is marked. Well, what do we know about 1 and 3? Well, we know 1 and 3 are vertical angles, and because they're vertical angles, we know they're congruent. So those are our two. The first one we say they're vertical angles because we have a definition of vertical angles, and once we know they're vertical angles, we can say they're congruent by the vertical angles theorem. Whoops, I jumped ahead. So now that we know 1 and 2 are congruent, and what are 3 incongruent, we're going to use this transitive property. What do we know about these angles? Well, 1 is congruent to 2, 1 is congruent to 3, therefore 2 is congruent to 3 as well. So now we know 2 is congruent to 3. Well, what do we know about congruent angles that are, what types of angles are 2 and 3? So 2 and 3 are corresponding angles, so that we can prove that P is parallel to Q because of the converse of the corresponding angles theorem. You've got to make sure it's not the corresponding angles theorems, it's the converse. If we're going from an angle to a parallel, it's the converse. If we're going from parallel to an angle, it's just the corresponding angles theorem. So sometimes you just have to pay attention to make sure you know which direction you're going. In this lesson, we're always going in the direction of the converse, almost always. So when we're writing proofs, this one here is our setup, and you'll notice we've got these little symbols over here, and we want to complete the 2-column proof. And there's lots of lines here. So some of the lines we need to know about and some we don't. So let's just try to identify this. M and N are parallel. So I'm going to mark my little lines here. M and N are parallel. And we want to prove, oh, we also know 1 is congruent to 3. So this angle and this angle are congruent. And we want to prove that P and Q are now parallel. So based on the things we know, what the next step, if we know angle 1 and M and N are parallel, which one is an alternate is going to use the alternate interior angle? Well, 2 is our alternate interior angle, right? Because we know M and N are parallel, then 1 and 2, because they are alternate interior angles, we know that angle 1 is congruent to angle 2. Then we're given that angle 1 is congruent to angle 3. So based on parallel, we know those are congruent. Then they're given us that 1 is congruent to angle 3. So what can tell us now that 2 is congruent to 3? Remember, that would be the transitive property. Those are the ones that when we have two sets of things congruent, then those two are congruent. And then finally, how can we prove that P is parallel to Q? Well, we have 2 and 3 are congruent. What types of angles are those? Those are corresponding, so it is the converse of the corresponding angles theorem that lets us know that. So angle 1 is congruent to angle 2, the transitive property goes here, and the converse of the corresponding angles, because if we have congruent angles that are corresponding angles, then those two lines are congruent, are parallel. Parallel. So now let's apply this. What are some unknown values? So if M is parallel to M, what is X? Well, what types of angles are these? They are alternate exterior angles, and we know alternate exterior angles are equal to each other. So we're just going to solve this for X. So we get 120 equals 3X. Divide by 3, so we get 40 equals X, or X equals 40, because it's asking for the value of X. So here's some more. You want to write these down just so you know them, and they might need to do them using in your homework assignment or when you're doing proofs. But there are converses. If each one of those theorems that we had in our last section, the converse is also true. So corresponding angle says if we have two angles that are corresponding, then the lines are parallel. The same side says if we have two angles that are on the same side that are supplementary, then the lines are parallel. Converse of alternate interior says if we have two angles on alternate, like 3 and 6, those are congruent, then the lines are parallel. And the exterior angles is if we have exterior angles that are congruent, then those lines A and B are parallel. So pause the video and write that down in your notes. Make sure you understand what that means. So which theorem justifies why M and N are parallel? We have two lines cut by a transversal and we have 50 and 50. Well, what types of angles are these? Those are alternate interior angles. And so it would be the converse of the alternate interior angles theorem that would make M and N parallel. So which diagram shows lines cut by a transversal? Parallel lines cut by transversal. Well, just by eyeballing it, they all look parallel, but we've got to look at the angles. What do we know about corresponding angles? They have to be congruent. 80 and 75 are not congruent, so this one is not. Alternate exterior angles have to be congruent. 85 is not congruent to 81. Same side interior angles have to equal 180 degrees, and those do, so then these two lines are parallel. So even you can't just eyeball it, you have to actually look. So let's look at, if we have X, Y, and Z are angle measures, which one of these things are true? What do we know about them? Well, we know X and Z are corresponding angles, so they are congruent, they are equal. It will guarantee that P and Q are parallel. X plus Y, so X and Y are same side interior angles, and if those add up to equal 180 degrees, then P and Q are parallel. X plus Z, we don't want them to add up to equal 180 because they're congruent. So that doesn't, they could if they were 90 degrees, but that doesn't always guarantee that they're parallel. X equals Y. Again, X equals Y, we want those to add up to 180 degrees, and the only way that will be is if they're both 90 degrees, but it will not always be the case. And if Z is 180, it actually makes a straight line, so that's not going to do it either. So it will be these two at the top. Okay, here's another two-column proof. And there's lots of lines, and there's actually, we have one set of lines that are given parallel, and we want to prove a different set of lines are parallel, but we don't have anything clearly labeled as transversal, so we kind of have to look at this carefully. The first thing we're given is angle T. Angle T is congruent to angle V. And we have ST is parallel to VU. So we're looking at these two lines, TS and VU right now. So that would make TU a transversal. So if I wanted to make that a transversal, I'm just going to kind of extend this line here. So it's a little bit easier to identify the transversal. So we've got these two lines cut by a transversal. So what do we know about angle T and angle U? Well, two lines cut by a transversal, we know that alternate interior angles are congruent. And what statement shows us that? Well, that would be alternate interior angles are congruent. So then we're given that T is congruent to V. So what does that tell us about U and V? Well, remember our lovely transitive property that I told you we'd use a lot? That's going to be our transitive property, that now we can say that U is congruent to V. And when we know these two are congruent, how does that make TU and VW parallel? Well, let's take a look. If we have TU and VW, now VU is our transversal, and what type of angles are those? Well, they're alternate interior angles as well, so if we use the converse of the alternate interior angles theorem, then that will tell us that TU is parallel to VW. So when we first have it and we're given alternate interior angles are congruent, or parallel lines, then we can say that the alternate interior angles are congruent by that theorem. When we're given alternate interior angles and we want to prove line parallels, then we use the converse of the alternate interior angles theorem. So that gives you an example of how to walk through a proof. Hopefully that helps you. Make sure you understand the difference between something like the alternate interior angles and the converse, but both of them are dealing with parallel lines cut by a transversal and congruent angles. So it just depends on which way you're going. So let me know if you need any help.